Hello students, hello viewers. Welcome to Senior College Mathematics. Topic of discussion is quadratic equations. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAM, or any other entrance or external examinations into high school, this topic, this lesson is for you. So let's start by looking at the meaning of quadratic equation. A quadratic equation is the group of equations in which the highest power of the unknown quantity or variable is 2. We have various forms of equations, but the one we are talking about, the variable you are interested in, the highest power is 2. So we refer to such group as quadratic equation. The general form of this group of equations is as squared plus bs plus c. What this means is that there's a form that helps us to identify all quadratic equations, and that form is as squared plus bs plus c. Here, a variable of interest is s, where a, b, and c are constants such that a is not equal to 0. Of course, a, b, c, they are numbers. They can be 1, 2, 3, 4, and so on. For us to keep on having quadratic equation, the coefficient of s square a must not be 0. This is what happens when a is equal to 0. When a is equal to 0, if you multiply s square by 0, you have 0. The result becomes a linear equation. This is why for us to have quadratic equation all the time, the term that contain the highest power of 2, its coefficient must not be 0. So that is the condition for us to have quadratic equation. Methods of solving quadratic equations. There are 4 methods employed when solving quadratic equations. Method 1 is factorization, 2 completing the square method, 3 formula method, 4 graphical method. In this series of teachings, we talk about all these methods. When we come to algebraic graph, then we discuss the graphical method along other graphs such as linear graph, simultaneous equation graph, we have trinomial graph. We look at all together. Are you following? Lesson 1, making quadratic expressions perfect squares. To make a non-perfect squares quadratic expression to be perfect squares, first, that is the first thing you must do, make the coefficient of the first term of the given quadratic expression a perfect square. The coefficient, that is the ordinary number standing by the first term, it must be a perfect square. That is the first thing you must do. Secondly, then square half of the coefficient of the middle or second term in order to obtain the third term. You square half of of the coefficient of the middle or second term in order to obtain the third term. This is because the middle or second term of a perfect square is always plus minus twice the square roots of the products of the other terms. So the middle or second term of a perfect square is always plus or minus twice the square roots of the products of the other term. That is the first term and the third term. The meaning is that another way to get the middle term or second term is to take the square root of the first term and the third term and multiply both together. When you do all of these, you can make all non-perfect squares quadratic expression to be perfect square. Examples. The instruction is find the terms that must be added to the following quadratic expressions to make them perfect squares and factorize completely. Number 1, s squared plus 12s. We are looking for the term when added to s squared plus 12s, it becomes a perfect square. We have two methods of doing that. So let's take method 1. We said that in method 1, make the coefficient of the first term a perfect square. Coefficient of s squared is 1. If you take the square root of 1, you also have 1. So it's already a perfect square. Then step 2, square half of the coefficient of s, the second term. Coefficient of s is 12, so you take half, that is 1/2 of 12 all squared. Half means 1/2, then off is times, so we have 1/2 times 12, and that is 6. Then you square it. When you square 6, you have 36. So 36 must be added to the other terms. So you have s squared plus 12s plus 36 is now a perfect square. Then we are asked to factorize completely. To do that, we have it that s squared plus 12s plus 36 is equal to, what we do is we look for two the same factors of the constant term, that is 36, whose sum is 12. Here there are other factors, but two the same factors. That must be 6 plus 6. So we have plus 6 and plus 6. So we have s squared plus 6s plus 6s plus 36. So we can write this as twice, that is 2 times 6s. And when you factorize, you have s plus 6 all squared. S plus 6 all squared. So that is the complete factorization. Okay. Method 2, let s squared plus 12s plus k be a perfect square. So that number that must be added, we assume that number to be k. So we add k to it and look for k. Now secondly, anytime you factorize a perfect square is always in this form. So again, we assume that s plus a is a perfect square. Now this is how it goes. The plus a you have, that plus sign is the sign attached to the middle term. That is the sign we have between s and a. What we do is that since s square plus 12s plus k is a perfect square, and when we factorize a perfect square, we have something like this. We have to equate both together. That is s square plus 12s plus k is equal to bracket open s plus a bracket close all square. We continue by expanding the right hand side of the expression. So if you expand s plus a in bracket all squared, you have s squared plus 2sa plus a squared. You write the bracket 2 times, that is s plus a, another s plus a, then you expand it. You have s squared plus 2sa plus a squared. What we do next is to compare coefficients of s. This is s in the right hand side, then you have s in the left hand side. When you compare that coefficient of s here is 2a, that is the right hand side, then the left hand side is 12. This is what I'm saying now. You have 12s equal to the right hand side, you have 2s, then you have a. When you equate, it means this s cancel this s, you are left with 12 equal to 2a. To get a, divide both sides by 2 and a is equal to 6. Next, you compare coefficients of the constant term, or better still, we compare the constant term. Constant term, they are term without variable, so they don't have coefficient again, they're already constant. So when you compare the constant term, the constant terms are a square and k. When you compare them, you have k equal to a square. From the previous comparison, a is equal to 6, so you put 6 in place of a. Since a is squared, you squared 6. That means k is equal to 36. So 36 must be added to the expression. So if you add 36 to replace k now, you have s squared plus 12s plus 36. And what is a? A is 6. So this is the complete factorization of that perfect square. Hello. Number 2, make 2m squared minus 3m a perfect square. Solution. Remember the first step, the coefficient of the term that is squared need to be unity, that it need to be 1 for it to be a perfect square. So we need to divide 2m square minus 3m by 2. 2 is not a perfect square. The only way to make that coefficient of m square a perfect square is to remove 2, and that is possible when you divide through by 2 and you have it in this form. So you have achieved that. Then step 2, you square half of the coefficient of the middle or second term, that is coefficient of m. Coefficient of m from the current stage is minus 3 over 2. Half of it, that is 1 over 2 of. And of means times. So we have 1 over 2 times minus 3 over 2. Then you square everything. When you multiply, you have minus 3 over 4 in bracket all square. Minus 3 square is 9 and 4 square is 16. So you have 9 over 16. So 9 over 16 must be added to the other terms. So we have m square minus 3m over 2 plus 9 over 16. We are not going to stop there. What we did now is to add 9 over 16 to the other terms. Yet it is not in perfect square, because in perfect square this term must be present. The term given to you, they must be present. To achieve that, from this step, what do? We multiply through by 2. So you multiply through the expression by 2 to make it looks like the original. So you have 2m squared minus, if you multiply 3m over 2 by 2, you have 3m. If you multiply 9 over 16 by 2, 2 will divide 16, it becomes 8. So you have plus 9 over 8. Therefore, 9 over 8 must be added to 2m squared minus 3 to make it a perfect square. So you don't just conclude until in your result the original expression is found there. That is why we didn't stop at this point. So to achieve the original expression, we have to multiply through that expression by 2. Hello. So let's take the second method to solve the same problem. In that method, we assume the term that must be added and add it to it. So that term is k. So we add it to 2m squared minus 3m. Then we look for k. After adding it, we try to get the result when you factorize the perfect square. Now, this is the result that we have. This is what happens then. We are having am because the term m squared here has coefficient of 2. So in the solution, we assume it to be a. Then this minus sign is the sign for the middle term, and this b is the other constant. Now when you factorize the perfect square, you have the variable plus minus a number. That's the number we assume to be b. After that, we equate the first expression to the second one, that is 2m squared minus 3m plus k equal to, bracket open, am minus b all squared. We expand the right hand side of the expression. So that is, you expand am minus b all squared. When you expand it, you have a square m squared minus 2amb plus b squared Okay, so here we compare the coefficient as well. So we start by comparing the coefficient of m squared, because m squared has some coefficient. This is m squared here, and this is m squared here. The coefficients are 2 and a squared. When you compare them, you have 2 equal to a squared. You label that equation 1. Next, we compare the coefficients of m. This is term that contain m here. The coefficients are minus 2ab, and the other side, this is m, the coefficient is minus 3. So we have minus 3 equal to minus 2ab. If you multiply through by minus 1, you have 3 equal to 2ab. You label it equation 2. Okay, we want to do something here. But let's square both sides of equation 2 because of this term that is squared in equation 1. When you square both sides, if you square 3, you have 9. You square 2, you have 4. If you square a and b, you have a squared, b squared. So let's make b squared the subject. Already we know a squared. Let's get b squared now. Divide both sides by 4a squared. So b squared is equal to 9 over 4a squared. Then we compare the constant terms. Compare the constant term, not their coefficient. When you compare the constant term, you have b squared and k, and they are equal. So you have k is equal to b squared. From equation 2, when we square it, we have b squared equal to 9 over 4a squared. Since k is equal to b squared, it implies that k is equal to 9 over 4a squared. You see what happened there now? Alright, so we need to replace a square, but from equation 1, a square is equal to 2. So when we come here, we have k equal to 9 over 4 times 2, because a square is 2, and that is 9 over 8. So this method produces the constant directly. We don't have to multiply through by 2 as we did in method 1. So therefore 9 over 8 must be added to 2m squared minus 3 to make it a perfect square. That is what you have there now. Then complete factorization. First, we need to clear the fractions. To clear the fractions, you multiply through by 8. When you do that, you have it in this form, multiply through by 8. This is the resulting expression. We don't need this again. Okay, now to avoid all other procedure now, so let's come here. We already have the result here, am minus b. Now this is what happened. The first term, want to get a now, the first term must be perfect square. So you have 16 and m squared. 16 is a perfect square. For us to have a now, the first term must be a single term, so we have to square 16, or we look for a number that we can square to get 16, and that is 4 square m squared. When you group everything, you have 4m in bracket and you square it. So if you have 4m in bracket and you square it, you will see that this a, you have, you see now, am. So we are taking 4m all square. So a is 4. So we have 4 here. If you square the, if you look for a number that can give us 9 when squared, that is 3 square. So b is equal to 3. So the complete factorization is 4m minus 3 all squared. Hello. Before the conclusion, I want to explain how the expansion of this leads to this, so that we have a complete understanding. So this is the term now, am minus b all squared. Because of the square, you write it 2 times, something like this. When you are expanding, you take all the terms in any of the bracket or the first bracket to multiply the second bracket. So the first term in the first bracket is am, is am multiplied by the second bracket, and the second term in the first bracket is minus b multiplied by the same second bracket. So you have am times am, that is a squared m squared, am times minus b minus amb, amb. Then if you come here, minus b times am, the same minus amb. Then minus times minus is plus, b times b, so you have plus b squared. These two terms are alike. Like you say you have minus 1, minus 1. You are owing one person 1, another person 1. You have you are owing minus 2 altogether. So minus amb minus amb is minus 2ab. So the final result there is a squared m squared minus 2ab plus b squared. So that is what happened. Okay, so let me repeat this step again. In order to have the complete factorization, remember we said in the introduction that the square roots of the first term and the third term, when you multiply it, it gives the second term. That's another approach to explain it. Okay, but I compared it with this since we already know the solution. So we have am, not am squared. So we need to get am from 16m squared. So we have to express 16 as 4 square, so that when you factor upward of 2, you have 4m, then brackets open to the power of 2. So you can see it clearly now that a is equal to 4. Then we also write 9 such that the square of the new number will give us 9, and that is 3 square. So clearly b is 3. The sign that connects the first term and the sign that connects the first term here, 4m, and the second term 3, is the sign from the middle term here when you are considering the whole expression, and that sign is negative. So you have 4m minus 3 all square. So this is how we make a given non-perfect quadratic expression a perfect square. Hello. End of lesson 1. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. Lastly, if you are not saved, your life is in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, I tell you, big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.